Circle channel, and today we'll talk about Uber system design. We'll look at the Uber system and software architecture. As we know, Uber provides majority two services. We can book the ride, or we can book the food from Uber Eat. Okay, these are the two major services that is provided by Uber, and this company is global in nature. Like worldwide, you will find Uber cabs. Okay, so let's first understand what is Uber, how it started. Okay, now to give you a glimpse, like when Uber started, it was not global in nature. So Uber started with a monolithic structure. So when we say monolithic, it means all the services that is needed is bundled inside the single project and is hosted on the single server, and then server can scale, of course. But primarily the project code, everything is inside the single. There will be single source code for it. So the various services such as users, trips, payments, products, cities, documents, background check, vehicles, trip management, everything is inside a single code base. And as we know, monolithic is very hard to scale, so that's why they moved to the API structure. Okay, once they move to the API structure, like as we can see here, when we access through either mobile or web device, or through some browsers, it goes through API gateway, and behind the scene there lies multiple servers which is responsible for multiple separate work, and each of these servers are a separate hosted microservices. Okay, now Uber follows domain driven microservice architecture. Okay, so those who are not much familiar with the domain driven design, please go and watch some tutorials on domain driven design and architecture. Okay, so one of the important thing that we need to understand, how Uber, when we try to book a cab, how Uber allocates you the cab near you. Okay, so to understand that, let's first understand with the help of an example. So suppose you are a user, and you are a passenger and you want to book a cab. Uber doesn't work like the nearest cab is allocated to you. Like in this example, you can see that in the bird eye view you can see the nearest cab, but when we actually go and see the routes, it's not actually the same. Okay, so routes are divided into multiple sections that can have traffic, and that will have more length in nature compared to the bird eye view. Okay, so typically when we try to book a cab, it tries to see the real location, and to do that it uses Google Map, and the library is using Google S2 library, it is using for that. Now let's try to understand one of the use case. So suppose here we have passenger A, and we have another passenger B. Now if passenger A try to book a cab, and we can see there is two cab available as well. So for passenger B, if we'll try to allocate cab B, then it will take around 9 minutes, and if we'll try to book and allocate cab A, it will take 2 minutes based on the routes. So it will not, but Uber and doesn't allocate like that. Okay, because here we can see the waiting period goes to 11 minutes, 9 minutes for user B and 2 minutes for user A. Okay, even though A is nearest to cab A is nearest to user A, but it will not get allocated because for the user B, this for 9-minute cab waiting, it will not work for the user satisfaction. So this user will get irritated and will book from the another cab. So Uber always try to see how I can improve the user experience, how I can reduce the ETA, estimated time of arrival for cab, for all the users of the system. Okay, to do that, what Uber will do typically, it will check all the available cabs which can reach to user, and how we can reduce the total ETA, that is the estimated time of arrival for all the users, not only one user. So if there is a route from for cab A to reach to cab B, which will be suppose 4 or 5 minutes, and if B can reach to cab B can reach to user A in 4 to 5 minutes, then in that case the total waiting period for each of the user will be just 4 minutes. Okay, so that is not much, and 4 and 4, which is 8 only. Earlier, if cab B will be allocated to user B and cab A will be allocated to user A, then it will be total 11 minutes. So Uber algorithm, with the help of Uber algorithm, it will try to reduce the ETA for both the users, and so here it will choose allocate. Here it will allocate cab A to user B and cab B to user A, and hence the ETA will be reduced for both the users. So this is about the algorithm of Uber. Now let's try to see the design of Uber, how it is, and so the microservice design that Uber follows, it's hard to represent for each microservice. I went through all the documents that Uber engineering provides. If you will get time, please go through this document which is published by Uber. Now here you can see that Uber has more than 2000 microservices, so it is hard to represent all the 2200 microservices on the design, but I'll try to explain that in some simpler way so that you can understand as a user easily. Okay, so let's first try to understand how it will work. So on a high level, as we know, there are two kinds of user. One is the passenger, and another user is the driver, taxi driver. These are the two major users of the system, and then we have and to access it, Uber provides access through either mobile app and also through the web app, that is through the browser. So user can access through mobile app, or user can access through browser. I'll be using Chrome for it, representing browser. User can access and this is accessible from all the browsers and from all the mobile apps, let it be Android, iOS, everything. Okay, let's buckle it together. Now user will access the Uber app through one of the device, but it doesn't go directly to the server. First of all, there is a firewall, web application firewall, or WAF we call it. Okay, so there is a WAF which is available. Maybe I'll delete it, it's not AWF. So it's kind of firewall, web application firewall, that acts as a security layer to filter out unwanted access. So if there is suppose some hacker who wanted to access the system, he or she will not be allowed to access the system. Or if someone is doing some suppose DOS or DDoS attack, that can also be prevented through it. So in this case, the legitimate user or the authorized user can access the system, and if you are not the authorized user, then you will not be allowed to access the system. Okay, so this, so that's about the security, first layer security. Then to since we know that Uber has a lot of user, like millions of user, active users Uber has across the globe. So single server will not work, even the single cluster will not work, so it uses a lot of load balancers, a lot of cluster. Okay, so it uses a lot of load balancer to access. I will not be representing all. I will try to showcase by an example. Then if you are eligible user and the multiple microservices are available, so suppose you are one of the microservice, and so there are plenty of microservice which is available. Primarily there will be one user management, or we'll call it passenger management. And all these microservices will communicate through REST API. Okay, so there will be some sort of, and let's club these together, so it will represent like all the microservices that we are seeing here. Okay, so we have microservices which will communicate. Okay, and load balancer is typically there to make sure that they communicate through load balancer. Now each microservice can again fall inside load balancer, again inside a load balancer, because user management, so even independent microservices can be accessed through load balancer, just to make sure that load due to load system should not fail. So with this, let me try it. Yep. So apart from passenger management, we will have driver management microservice as well. Now this passenger management and driver management, so the one important task that I explained, how to allocate the cabs, we'll call it find cab, or so we'll call it find ETA or find cab. Okay, which again, as I told you, uses Google Map to access the location and find the nearest and shortest path available, and to show the user in real time. And it uses Google S2 library. Now apart from this, it also has multiple microservices such as and these microservices communicate with each other through REST APIs, or sometimes through Kafka streams as well. So we have apart from this, we'll have some user service, passenger user service, like profile for passenger profile. Then we will have now driver, and then we have something called driver service for driver profile management. Then we'll have microservice for payment, and for payment they use Stripe basically. And so the issue with Stripe is like it's not allowed in all the countries or not accessible, so in different countries they use different payment solutions as well, so payment is not generic. Then they have this billing, and then they have this trip management. Then they have analytics. Then these are some common cross-cutting concerns. Analytics, and apart from analytics, they have logging. They do have audit management system. Okay, and let's try to arrange this, and let's club it together, club these services together. Okay, so the primary microservice that we have, passenger management and driver management, which then interact with other microservices to make sure to get the work done. Okay, so it comes something like this. And so apart from that, they also uses Kafka heavily. Kafka again is in falls with some load balancer, within some load balancer. So that Kafka will also not and different microservices can send and receive communication through Kafka streams. Kafka helps a lot. So it is able to read and write millions of records within a second. None of the record will get lost. It will stay in the Kafka queue. Okay, so this driver management, then passenger management, we'll write to Kafka. Okay, this is Kafka stream. For database persistent, they use for RDBMS they use PostgreSQL. Let me see if I have this PostgreSQL. Yep. So every microservice has can have their own database. So for RDBMS, they use Postgres. And for unstructured data, they use some flavor of NoSQL database as well. SQLDB. Okay, now this can be this Postgres and NoSQLDB can be linked centrally, is linked centrally as well as linked independently as well. Like driver management can have its own set of database to manage certain thing. Then participant can have its own set to manage. Otherwise centrally also they all read and write to this streams. Okay, it's hard to represent. So these are primarily the major microservices that is used. Passenger management. So when request comes from browser or mobile app, it first goes through web application firewall. If it is a legitimate request, it goes through load balancer. Now there is not single load balancer, it can be a cluster, and then each microservice can fall within its own load balancer. And then different other microservices. So passenger can find the cab, driver can also locate the passenger, and then the payment can be done, billing can be done, trip management can be done, like that. So on a high level, this is the architecture that I can think of for Uber system design. If you guys have any questions, please write in the comment box, and if you find the video helpful, please like the video and subscribe the channel. And important thing is, if you have any if you want to learn more in detail, please visit this site engineering.uber.com. This has detailed, this is published from Uber itself. So while making this tutorial, I went through this before writing or publishing on the YouTube. So I would recommend you guys also to go through that if you want to know more. And if you want us to make videos on system architecture for some other apps as well, please write in the comment section. So thank you viewers for watching the video, and do subscribe the channel. Thank you.